Here's a classic. A bird and a train are heading towards each other. The train travels at a cozy 50 kilometers per hour, while the bird races at 80 kilometers per hour. Once the bird reaches the tip of the train, it will turn around and fly back to the station. Once at the station, it will turn around again and fly back to the tip of the train. It keeps doing this until the train reaches the station. If the bird and the train were originally 100 kilometers apart, how much distance does the bird cover? This is actually an interesting problem because it enters into the mathematical realm of supertasks. Supertasks are processes with infinitely many steps that occur in a finite amount of time. How can this be? As the number of steps approaches infinity, the time needed to complete each step approaches zero. In our case, the bird always arrives at the station before the train as it is faster and then has time to do one more step. Thus, one way to figure out the solution to the train-bird problem is by adding up all the segments the bird flies. On paper, there are infinitely many segments. Thus, the total distance must be described by some sort of infinite series. Before we dive into the infinite series, you should know that there's a little trick to find the solution much quicker. Ignore the path of the bird. Calculate the total time the train takes to reach the station by simply dividing the total distance by its speed, which will get you 2 hours. Since the bird keeps flying until the train reaches the station, it will therefore also travel for 2 hours. And since it travels at 80 km per hour, we know that it will therefore fly a total distance of 160 kilometers. For all you math nerds out there who are still with me, let's figure out the hard way, shall we? Instead of figuring out an expression for the distance, let's find a series for the time the bird takes to fly the distance. This expression we can then multiply by the bird's speed to get the final expression for the distance. The first segment lasts until train and bird meet, which is after 0.77 hours. Twice that time and the bird has finished its first rotation. The second rotation can be found in much the same way, only that this time we need to first find the initial distance between the bird and the train at the beginning of the second rotation. Just subtract from the distance you had before the duration of the first rotation times the speed of the train. And there you have it. Now we can calculate the time the second rotation takes. And then repeat, which of course leads you to the infinite series. In its general form, it's a fairly long expression, but we can naturally reduce it. Add the bird's speed into the mix, and thus you get the complete expression for the total distance. While some of you might have spotted the trick instantly, not everyone does. Pose this problem to friends of yours of different academic backgrounds and see which approach they take first. My observation has been that mathematicians tend to start out by solving the series, while engineers generally spot the easy way instantly. The story goes that mathematician Leonhard Euler was given this problem by a friend. Euler instantly replied, 160 kilometers. So his friend goes, "Ach, so you know the trick. You know, you can also solve it using infinite series." To which Euler replied, "Yes, how else would I do it?"